Welcome back, geometry students. Today we're going to be continuing on with our proving angle relationships. Couple things we need to know: congruent angles, the reflexive property of congruence, symmetric property of congruence, and transitive property of congruence all hold true for angles. So when we did the line segments, proving line segments last, we had the reflexive property. So the reflexive property is just this: angle A is congruent to angle A. It's always congruent to itself. The symmetric property is this: if angle A is congruent to angle B, then that also means that angle B is congruent to angle A. You can say either way. The transitive property is this, and it holds true just like for angles. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So I'm just going to show you this real quick. The reflexive would be angle A is congruent to angle A. The symmetric property would be angle A is congruent to angle B. And we can also say angle B is congruent to angle A. So symmetric means both ways, it's the same. And then we'll do the transitive property. It says this: angle A is congruent to angle B. So this is an if statement. If angle A is congruent to angle B and angle B is congruent to angle C, then angle A would be congruent to angle C. So we have a couple more theorems here. We have a couple things that you guys should be looking at. You should be memorizing. You should write it down in a notebook. Do whatever you can. These will show up again. We are going to be seeing these things as we continue on. So the congruent supplements theorem. Angles supplement to the same angle or congruent angles are congruent. So when you have two angles and they're congruent to the same angle, then they have to be congruent, is essentially what it's saying. Or when they're supplements to another angle, those two have to be congruent. And the same thing falls for complements. Supplementary angles are when they add up to 180. Complementary angles are when they add up to 90 degrees. So vertical angles theorem: if two angles are vertical, then they are congruent. We've showed this. So that means if I have two lines, intersecting lines, vertical angles would be angle 1 and angle 2. They're vertical from each other. And then the 3 and 4 are vertical from each other. They are across each other. So they are equal. Theorem 2.9, perpendicular lines intersect to form four right triangles. So what that's saying is if I have perpendicular lines, two lines here, they intersect and they make four right angles. So all of these are right angles. That's what Theorem 2.9 is saying. Theorem 2.10, all right angles are congruent. Well, all right angles are congruent because all right angles equal 90 degrees. So that's true. Theorem 2.11, perpendicular lines form congruent adjacent angles. So if we have two lines, all right, we have two lines. Our first line is here, and then our second line is perpendicular, so we'll draw it here. They form two congruent adjacent angles. Why do they do that? because they form 90-degree angles. And remember, the box means that we're drawing 90-degree angles. So that's Theorem 2.11. Theorem 2.12. If two angles are congruent and supplementary, then each angle is a right angle. So remember, supplementary angles, they form a linear pair. So if two angles are congruent and they're supplementary, that would mean that it has to be like this. It has to be that they're two 90-degree angles, because that's the only way you can get them to equal 90. So essentially, if two angles are congruent and supplementary, then each, and we're also going to do this one, I'm sorry. If we have, that's not entirely how they're explaining it. So they're explaining it like this. If I have an angle here, and I have another angle here, and they're two congruent angles, so we'll say that this is angle B, and we'll say that angle A. So they're two congruent angles. So what they're saying is angle A is congruent to angle B, and they're supplementary. That would mean angle A, measure of angle A plus measure of angle B would have to equal 180. The only way that can happen is if measure of angle A is 90 degrees because they're congruent, and measure of angle B has to be 90 degrees as well. So that's what they're saying. Theorem 2.13. If two congruent angles form a linear pair, they are right angles. That's this right here. Two angles forming a linear pair and they're congruent, then they have to be right angles. So let's go do this example together. Write a two-column proof. If angle ABC, so I'm going to highlight this as we go. Angle ABC, and CBD are complementary. So that would mean angle ABC, so I'm going to write down what that's telling me. Measure of angle ABC plus measure of angle CBD. If they're complementary, they have to equal 90 degrees. So I'm writing down, kind of collecting my thoughts as we go. Then they tell us that angle DBE and CBD, which is in red, form a right angle. So now what are they telling me? Angle DBE and angle CBD, they form a right angle. So what does that tell me? Right angles, they measure up to 90 degrees. So they're telling me that measure of angle DBE plus measure of angle CBD are going to equal 90 degrees. And they want us to prove, this is what they want us to prove, angle ABC is congruent to DBE. So before I even look at the proof, I want you to understand what's going on here. Angle ABC plus CBD is 90 degrees. That's given to us. DBE plus CBD is equal to 90 degrees. That's also given to us. So if you notice, we have CBD here and CBD here. So that tells me, and then we have 90 degrees, 90 degrees. That tells me that ABC has to equal DBE. So they start off with writing out what's given. Angle ABC and CBD are complementary, which means 90 degrees. And DBE and CBD form a right angle, which again is also 90 degrees. So we can jump right to this. Angle DBE and CBD are complementary because the complementary theorem says that 90 degrees. They add up to 90 degrees. Now we can say angle ABC is congruent to angle DBE. Why? Because when we go back here, angles complement to the same angle or to congruent angles are congruent. Angles complementary to same angle or congruent angles are congruent. And that's it. So let's go ahead and do a couple examples together. The first one, each proof. Complete each proof. Angle or segment AB is perpendicular to BC. So AB is perpendicular to BC. So we have AB here, and then we have BC here. They're perpendicular, so we know that they form a 90-degree angle. So right off the bat, we know that that's a 90-degree angle because of definition of perpendicular lines. Angle 1 and angle 3 are complementary. So angle 1 and angle 3 are complementary. So what is that saying? That's saying measure of angle 1 plus measure of angle 3 also equals 90 degrees. So let's start with our proof now. They tell us AB is perpendicular to BC, and the reason is that is given. We already know that because it is given. It's given here. Now, they're telling us whatever our next statement is because of the definition of perpendicular. So, it's what I already wrote out here. ABC, so angle ABC is 90 degrees. How do we know? Because it's a right angle. So that's what our statement here is going to be. It's going to say angle ABC is a right angle. And I'll put this symbol. And then we're going to make that just a little bit smaller. So angle ABC is a right angle. Why? Because of definition of perpendicular lines. Then they tell us measure of angle ABC is 90 degrees. Well, it's 90 degrees because that's the definition of a right angle. All right angles measure 90 degrees. Then they tell us measure of angle ABC is equal to measure of angle 1 plus measure of angle 2. And that is the angle addition postulate. So we know that these two angles together, angle ABE, so angle 1 and angle 2 would have to equal angle ABC, and that's the angle addition postulate. So angle addition postulate. So we know again that ABC equals 90, so we can, instead of saying measure of angle ABC equals measure of angle 1 plus measure of angle 2, we're going to change ABC into 90. 90 equals measure of angle 1 plus measure of angle 2, and that's substitution. They give us that. Angle 1 and angle 2 are complementary. Complementary angles. So we know that they're complementary. Why do we know that they're complementary? Because complementary angles add up to 90 degrees. So we know they're complementary because they add up to 90 degrees, and that's definition of complementary angles. So that's the definition of complementary angles. Notice, now they go back to the given. And so what's given that we haven't already put in? Well, it's angle 1 and angle 3 are complementary. So that's what we're going to put in for our statement here. Angle 1 and angle 3 are complementary. Angle 1 and angle 3 are complementary. And we're left off with angle 2 is congruent to angle 3. and we're going to go back to this whole thing right here. Angles complement to the same angle or to congruent angles are congruent. So that's going to be our statement. So, and we're going to abbreviate as much as we can. Angles complementary to the same angle, or I'm going to put congruent angles, but I don't have the squiggly, so I'll have to add the squiggly to the same angle. And we don't have to say or same angle. Complementary angles complementary to the same angle are congruent. And that's all we need to put. And that's our answer. And so we just proved that angle 2 is congruent to angle 3 by using what we've just learned. Alright, our next proof that we're going to do, it's our last proof that we're going to do, and then you guys have to make sure that you fill out your answers. Angle 1 and angle 2 form a linear pair. So what we're showing here, angle 1 and angle 2, they form a linear pair, and we can see that by the picture here. So that means angle 1 plus angle 2 equals 180 because they are supplementary to each other. And then they tell us angle 1 and angle 3 equal 180. So angle 1 plus angle 3 equals 180. So they're supplementary angles. So right off the bat, we know what we're doing. We want to show that angle 2 is equal to angle 3, and by definition we already have that because we can cross out the angle 1s, we can cross out the 180s, and we're left with just angle 2 and angle 3. Angle 2 equals angle 3. So they list everything that's given. Angle 1 and angle 2 form a linear pair, and measure of angle 1 plus measure of angle 3 equals 180. They next go to supplemental theorem. So angle 1 is supplementary to angle 2. Why do we know that? Because they form a linear pair, and all linear pairs are supplementary. Angle 1 is supplementary to angle 3. Well, they gave us that. Angle 1 plus angle 3 equals 180. So they gave us that. That is the definition of supplementary angles. Definition of supplementary angles. So now, if you notice, they give us the reason angles supplement to the same angle or congruent angles are congruent. So essentially they're saying we've already proven what we wanted to prove. Angle 2 is congruent to angle 3. And I'm going to go and I'm going to write my swivel above the equal sign. Angle 2 is congruent to angle 3. And there you have it. We just proved what they wanted us to prove. Make sure you guys are filling this out. All right, have a good day, guys.